Okay, we're going to be doing Leetcode 2023, number of pairs of strings with concatenation equal to target. So let's first read the question. You're given an array of digit strings called nums and a digit string called target, and you're supposed to return the number of pairs of indices ij where I does not equal to j, such that the concatenation of nums at I plus nums of j equals target. So basically what they're asking us here is to find the number of pairs where if you concatenate them, not add them, concatenate them, you get the target. So this has 4 valid pairs, which is 777, 777. We have 7. We have 7 777, 777. We have 77. So for this, we obviously can't use a 2 pointers approach because they are not sorted. And the other option would be to use the hash map, but then if we use the hash map, we would need to convert these into a format. Each value would have to be converted into a format whereby we can subtract this from this and check in a hash map for, say, this, right? So there's something, this is why you need to look at the constraints, right? So the input sizes. So they've told us that the number of the sizes of these inputs, right, are going to be between 1 to 100 max, right? So the longest digit string is going to be 100 digits, right? And so nums at I dot length. And then the target is going to be between 2, right? The largest target is going to be between a string of 2 and a string of 100 digits. So 100 digits, that's like what? That's 10 to the power 10. So that's 10 to the power 10. So it's not large. It's not large. Let me first make sure 10 to the power 10. I want to. That is 100 digits. Okay, maybe a bit larger, but it's not big. You know, it's a small input size, right? 100. So for this, we're simply going to have 2 for loops, and we're just going to compare at every position at I and j from the same position. We compare, and if the index at I is equal to the index at j, we simply skip it. So this is one of those algorithms where I'm going to write the code first before showing the solution. So we need a count. So let me write the code first. So we need a count for the number of pairs, which are going to initialize to 0, and that's what we'll be returning. Then our first for loop is for I in range, length of nums, and then our second one will be for j in range, length of nums, right? So remember, if I is equal to j, so if I is equal to j, we simply continue, right? Otherwise, we check if when we concatenate the pair at I and the pair at j, I mean the number at I and the number at j, whether when we concatenate them, we get something equal to the target. So if nums at I plus nums at j we've concatenated is equivalent to target, that means we found a pair which when you concatenate is equal to the target. So we increment our count. right? And then we return count. Right, so let's see if this works. Voila. Right? So this is one of those that if you optimize it, you're going to get something like n times k, right? But this is one of those where you at best you can do it in some sort of quadratic time, right? So let's just draw it for the sake of posterity. Let's just draw this thing. So let me pull up my. So we're going to use the input. We're going to use the input 777 77 77 and then a target of our target is going to be quadruple 7, right? So we need to find how many pairs, which when we concatenate, for example, this with this, or this with this, or this with this. And the pairs are not based off the values, they're based off the indices, right? So for example, okay, this is 0, 1, 2, 3. One pair will be 0 to 1, another pair will be 1 to 0, right? So this is why the for loop really works well. So let's do the 2 for loops, right? So we have I and j, right? So we're going to have I and j here to keep track of where we are. It's going to be 0. Actually, you know what we should have our I and our j here, right? And then we'll have our indices below 0, 1, 2, 3. So we keep track of our I and our j values. And then we'll have a comparison for the concatenation. So is I concatenated with j, I'm going to call it conc, so like concatenation, is it equal to the target, right? And the target is quadruple 7. So we are at I, our index at I is 0, our index at j is 0. There's a small case we missed out here, which is I equivalent to j. So since I is at 0 and j is at 0, is I equivalent to j? Yes, we simply continue, right? So since we're at I remains at 0, but then j equals to 1, right? So we move our j to the position at 1. And then we say, is I equivalent to j? No, they're not. Oh, sorry. It's not equivalent to j. So we concatenate 777 plus 7 gives us quadruple 7. Oh, we also need our count here. So that means that we have found a pair, which when you concatenate, so increment our count to 1, and then we go to the next point. We'll be at 0, and this will be at 2, right? So we shift it here to 2. Are they the same? Is the index at I equal to the index at j? No, they're not the same. But when you concatenate 777 with 777, you do not get quadruple 7, right? So that means that this does not give us an answer. We simply continue, So we go to 0, 3, right? So our j is now at 3. So is the index at, so this is going to come out to the same exact outcome because it's going to copy these, right? And we'll just continue. So now that we've reached this end, we shift our I to the next position, right? And then our j comes back to the next position as well, which will be, hold on a second, our j will now start from here in its next loop, right? So I'm going to erase these. Loop. I think you get the gist of what we're doing here, right? Just going to erase this so that we can start on the next loop. So I is at 1, j is at 1. Is I equivalent to? Yes, so we continue. So now our j has moved to the next position. So our I is at 1, our j is at 2. Is I at the same index? No, we concatenate. When we concatenate, we get 7, 7, 7, which is not equivalent to 7, 7, 7. So we move forward. And this also does not lead to a value that we're looking for. The next one will also not lead to a value, right? So we simply push our I to the next position, and then our j will also be at that position, right? So again, I'm going to adjust these, and this is probably our second last loop. So now our I is at 2 and our j is at 2. Is I equal to j? Yes. So we simply continue. So our j moves, oops, might have to erase that. Our j is now at this position. So our I is at 2, our j is at 3. Is our index at I equivalent to the index at j? No, so we can concatenate. When we concatenate, we get quadruple 7, which is equal to that target. So we just found another count, right? So that's the second one. And then we iterate again to we iterate further. So we move our I to the position at j. But basically, you can get the gist of this because we're going through all the possible permutations. That's what we're doing here. So we're doing this in n squared asymptotic complexity because it's n by n, and the space complexity is of 1 since we don't have any other. So basically, don't waste your time on this. Just do, because we're already given a small input size of up to 100. So this is not a large input that would make quadratic time complexity an issue. So yes, that's the solution.